Hello, my name is Cezmi Akdis. I'm the director of the Swiss Institute of Allergy and Asthma Research and editor-in-chief of Allergy. I'm going to talk about epithelial barrier theory and the increased prevalence of allergy and autoimmunity, which is a huge problem nowadays. And I would like to also express it as a global environment and health crisis. We are facing the allergy and asthma pandemic. At the same time, a similar increase in many autoimmune diseases is taking place. When John Bostock published the first case, and when Charles Blakely published the first series in 1873, there was few allergy cases actually, and it took several years for Charles Blakely to collect the first 28 cases. When we come to 1900s, in the Swiss Army, there was also still 1% allergic individuals. But after 1960s, there was a very steep increase in allergic patients and asthma patients, and we are seeing here the numbers 4.4, 8.4%, and 20%, 28%, 26, 43%. And currently, we have about half of the population sensitized and one-fourth of the population clinically allergic. And we are seeing this at the same time together with an increase in chronic non-communicable diseases. In 1960s, there was around 20 to 30 million patients of chronic non-communicable diseases. Currently, we have 2 billion patients in the world. Around one-fourth of the world population has somehow one kind of chronic non-communicable disease. And we are seeing a second wave, and which started around 2000. And we have clear evidence that there was a very steep increase in food allergy, eosinophilic esophagitis, drug hypersensitivity after 2000s. Eosinophilic esophagitis was described in our institute in 1996, and there was a few cases. Currently, the prevalence of this disease is around 4%. Food allergy prevalence is 2 to 3% in the world, and before 2000, we were not talking about food-induced anaphylaxis. And after 2000, there was a very steep increase also in food-induced anaphylaxis. And in the same time, world population increased only 2 times, but the chronic non-communicable diseases, both allergic and autoimmune, increased very significantly. So what happened after 1960s is a major question. So this is the beginning of global health crisis. And we have seen that 350,000 new substances have been introduced to human lives. These are new chemical substances, and there was almost no control on their health effects after 1960s, and many of them ended as pollutants. Now we have registries that is following these compounds. Let's look at what are changing our lives a lot and what are making a reason for increased prevalence of allergic and autoimmune diseases. We have laundry and dishwasher detergents, surfactants, diesel exhaust, ozone, nanoparticles, enzymes and emulsifiers in processed food, shampoos and body cleaners, household cleaners, toothpaste, particulate matter, and microplastic in the list here. And these are the substances that we have data in our own institute with our own experiments. And what's happening is that the epithelial cells are not touching each other because these substances are all breaking the epithelial barriers. And they also show a synergistic epithelial barrier damaging effect. And this is causing a very general epithelial barrier damage. And the microbiome goes between the epithelial cells. And the barrier stays open, and allergens, toxins, pollutants, microbiome, opportunistic pathogens are all passing through the barriers and making an inflammation error. We published this epithelial barrier theory as a hypothesis in Nature Reviews Immunology about 2 years ago. And there you can go through in detail. So what we have as criteria to say that a disease is related to epithelial barrier theory is we have increased prevalence after 1960s or 2000s, which is not affected with the changing method of diagnosis. Another important criteria is microbial dysbiosis with loss of commensals and colonization of opportunistic pathogens. Then we have circulating microinflammation, and we have epithelial barrier defect and epithelitis. And when you biopsy these patients, which I'm going to talk about, you can see that their epithelial cells are inflamed and making IL-1, IL-25, IL-33, and TSLP. And when in these biopsies, if you look at the microbiome also shows decreased commensals and colonization of opportunistic pathogens. So these diseases are shown nowadays as comorbidities. They are not coming as a single disease. We don't have alone asthma too much nowadays. About 20, 30 years ago, asthma, rhinitis, atopic dermatitis, they were separate diseases, but now we have comorbidities and multimorbidities. And these are all linked to epithelial barrier impairment. And here is a list of diseases in which the directly affected tissue shows epithelial barrier defects. Atopic dermatitis shows skin barrier defects. Asthma shows bronchial epithelial barrier defects. And we have here chronic rhinosinusitis with sinus defects, allergic rhinitis, eosinophilic esophagitis, inflammatory bowel, celiac. And if we biopsy these tissues, we find two major things, and one of them is a very clear microbiota dysbiosis in the affected tissues, and the other one is in biopsies and air-liquid interface cultures, which are developed from these tissues. You can see that there's epithelial barrier is defective. The second group of diseases are autoimmune and metabolic diseases. And here there is gut barrier defect, and sometimes there is a lung or sinus barrier defect, and there is microbial dysbiosis. In this list, we have diabetes, obesity, fatty liver disease, autoimmune hepatitis, liver cirrhosis, rheumatoid arthritis, multiple sclerosis, systemic lupus, and ankylosing spondylitis. The third group of disease show also gut barrier defect and microbial dysbiosis, but the evidence for these diseases are not so strong, and the research should go on. We have here autism spectrum disorders with reduced tight junction barrier in post-mortem histopathology studies, Parkinson's disease, which shows intestinal biopsies and biomarker proteins are high, and Alzheimer's disease with enteric inflammation, barrier defect, and microbial dysbiosis. In addition, we have stress-related psychiatric disorders and chronic depression. So what happens is that the interaction between the microbes and epithelial cells is now broken. There was an agreement for several hundred million years for humans for 1 million years, for mammalians for about 50 million years. And the agreement was these organisms, the big organisms, are carrying the microbes in their tissues, on their skin, their gut, in their mucosal surfaces. And this microbiome interacts with the epithelium for digestion, for production of nutrients, vitamins, metabolites, immune system education, differentiation of cells, and tissue maturation. So the epithelium and the microbiome were living together, evolving together. They were selecting each other and supporting each other. So this millions of years of agreement is now broken after 1960s. And we see now that the epithelitis as the first word, which is starting with the microbiome migrating deeper inside the epithelium, and that gets in contact with the basal epithelial cells and stimulates the immune system. And we have seen also translocated microbiome in sinus biopsies, in gut biopsies, and the immune system gets activated. First, the epithelial cells start to make IL-1, IL-25, IL-33, and TSLP, and this is increased alarmin production, and these alarmins activate the immune system, and the immune system migrates, and a general tissue inflammation starts. Together with this, neuroimmune interactions change the activation threshold of the cells, the mast cells, dendritic cell antigen presentation, T cell responses, B cell responses, innate lymphoid cells are all modulated. As a second pathologic event is expulsion response. So these microbes are now in a place where they normally shouldn't be. Normally they should be swimming above the epithelial cells, and they are, in this case, they are passing between the epithelial cells and going under the epithelial cells. So the immune system tries to get rid of these microbes that are going deeper. And this is an expulsion response, and the expulsion response has a very typical type 2 immune response character. Main players are IgE, eosinophilia, open barriers, cough, TLR2 response, innate lymphoid cell type 2 response, and main cytokines are IL-4, IL-5, and IL-13. At the same time, opportunistic pathogens are colonizing, and we are seeing in the respiratory tract Staphylococcus, Moraxella, Haemophilus, and Pneumococcus. And there is loss of biodiversity because of colonizing opportunistic pathogen and immune response to commensal bacteria. At the same time, there is detectable autoimmunity developing, and together with immune response to commensals and immune response to Staph aureus. The other important factor in this epithelial barrier theory is that circulating microinflammation, cells that are migrating in the circulation and moving to distant organs. So the cells are getting activated in the gut, but they go to brain, they go to joints to make these inflammations. Here we are looking at a section in the lungs or a section in the gut, and we can see that the epithelial cells in these sections are not touching each other. There's a distance between. Microbes are transmigrating and translocating below the epithelium, and the immune system is activated. And the activated immune system cells do not stay at the place where they are activated. They are migrating to distant organs. A T helper 17 cells migrates to brain to cause multiple sclerosis, or a Th1 T helper 17 cells come to the joints to cause or to exacerbate rheumatoid arthritis. There are several examples on this. CLA-positive skin homing cells are coming from gut to skin, and these were studies of Akdis during her PhD studies. And there is impaired gut barrier defects before diabetes onset. And joint migrating T helper 17 cells from gut. These are the work of Mario Zeiss for rheumatoid arthritis. And brain migrating T helper 17 cells from lungs in multiple sclerosis. And this was a study from Stockholm upon a very high dose of particulate matter exposure. This is the summary of today's talk. We have genetic reasons and exposure to barrier damaging agents and opening of the epithelial barrier, colonization of opportunistic pathogens, translocation of microbiota to subepithelial areas, immune response to commensals and opportunistic pathogens, loss of commensals, microbial dysbiosis and decreased biodiversity is taking place, inflammation in the epithelium and chronicity and chronic expulsion response is taking place, and defective barrier healing capacity of epithelium and chronicity. Then we have here 2 billion allergic, autoimmune, and neurodegenerative patients. So there is a direct toxicity to epithelium as the major event. This is followed by the epithelitis and followed by the expulsion response, which is expulsion of inflammation and deep translocated microbiota and migration of the inflammatory cells to distant organs. I would like to stop here by thanking all our co-workers, and I invite all of you to come and work in our institute. Thank you very much for your attention.